Now we are back after learning introduction to stats and R-keyword. Now we are going more into understanding how a data is and how do we describe data. Some of these commands we have touched in the previous week and we might touch them again. So please again pay attention and let's start. So in the last two classes we discussed how to make plots and how to process data, and now we will go further. So the agenda of today is we will learn about measure of central tendency. Now what is that? We will come to that. So why descriptive statistics is important? What is descriptive statistics? Descriptive statistics is describing the data, as the word says. So there are two branches of statistics, and I will repeat this again in further courses: inferential statistics and descriptive statistics. So when we say we are describing the data, it is called descriptive statistics. Okay. Now all the field of data visualization and other parameters like mean, median, average, all these are just describing the data. This is not yet analysis, please understand, which itself is very important. When we see Sachin Tendulkar's score, again we are taking the example of cricket which we took last time, the icon, the platform where the average, mean, number of sixes, number of fours, everything is saying, that is the description. Now from that we cannot understand what is causing this. As we went in the last week, if you go, there are two important parameters of statistics or important feature of statistics. One is summarizing, another is causation / association / prediction. Okay. So description of data is more into the summarizing part. Okay. So from the Sachin Tendulkar's data you cannot infer anything, you can just say this is the score. Now rank in everything, that is different thing, but you cannot say he scored by this or he scored on this pitches. That is the more data you need to go, or against this bowler and he so cover drives this much. That is what is description is. So coming back, so he need to understand what is the data all about. The manager needs to understand, and for this we have two branches, measures of central tendency and measures of variability. Again, measure of central tendency and measure of variability. Now I will describe them in detail more, but to give you a nutshell understanding of this, measure of central tendency is what if the entire thing is at one point. Okay. So when you have your Google Maps and the house shows some latitude, longitudes, that is actually a measure of central tendency, where it's saying okay, the complete house can be assumed to be imagined at a point. That is measure of central tendency, when the complete data can be assumed to be at a point for simpler calculations. Measures of variability is about the spread of data. Like you might have, let's say, a 2 biga plot in our place, or 2 acres of land or 5 acres of land. But if we have to say where is this land, when we say okay, this is at this particular location, so either it is 2 acre, 5 acre will not differ. The central tendency measure will be same, but the measurement of spread, measurability of spread will be different. It will tell okay, at this point this is 2 acre or 5 acres. So this is a brief understanding. We will go and have separate lectures for both of them. So now we are moving to measures of central tendency. Okay, this is the source from the book which we have taken the material. Right now we will be describing measure of central tendency: arithmetic mean, geometric mean, median and mode. Geometric mean will not be used that much in statistics right now, though if you want you can use it later. So please understand, these are there are harmonic means also. So if you go in mathematics side, there are multiple types of means. Okay, and we will not go in that details at which means is better right now mathematically, but statistically these are the practically mean, median, mode. These are the three things which are generally used for central tendency. Okay, and for variation these are the measure which we will talk later. Okay. So what is a good measure of central tendency? This is what we have to understand. It should be rigidly defined. As I told you, it should not be, we are assuming the complete data to be at one point. When we say at one point, that means it has to be rigid. Rigidly defined, not that it's a function of something. It has to be a fixed value, and it should not be that much flickering. Okay. It should be easy to understand, calculatable for even for a non-mathematical person. Therefore, if you see, average or mean is the most used statistic everywhere. The mean of this is this, the mean, everybody talks about average. The first thing when you come about how to find things, you will do is average out. Okay. It should be based on all observations, that is very important, and we will see that sometimes some observation can distort the value. It should be representative all the data, that is also important. What does representative of the data means? It should not happen, it is just like as we talk in sampling otherwise, that if I say the per capita income of India and we are just calculating per capita income of Mumbai or some other states, one state, then we cannot say it is per capita income of India. Okay. It's sampling stability. Now, sampling stability is very important. It should not happen the moment I add one more person in this, or one more data point in this, or one more entry in this, the value changes too much. Obviously, there has to be some change in the value, but simply it has to be stable. Okay. Again, last point, it should not be affected by extreme values, and we will come to that. What does it mean? Okay. And obviously, it should be useful for further mathematical treatment. Okay. Now, we will go again in detail little bit. So, this is a simple photograph which shows you the three different things. Average, mean, I assume everybody knows, it's the easiest things, x1 plus x2 plus x3 till xn divided by number of entries, that is mean. Okay. Median is the midpoint when it is sorted. Please understand, it has to be sorted. You cannot find median of a data which is not sorted. You can find mean of a data which is not sorted. You can find mode of a data which is not sorted, but you cannot find median of a data. So, median of a data is only possible when the data is sorted either in ascending or descending, that does not matter. Okay. The midpoint. The mode is the most observed frequency. So, please understand that. Okay. Mean is calculated for interval and ratio level data. It is not calculated for nominal, because if you see our graph, our slides earlier, nominal data is generally represented by a string or a character. So, we cannot have an average of a nominal data, and ordinal data is represented by a factor. Okay. So, we cannot say rank, I got rank 1 this time and last time I got rank 2, so my combined average rank is 1.5. Okay. No, it is not possible, because 1.5 does not make any sense, that is why. Okay. It is very sensitive to extreme values. Now, this is what I was trying to tell. Though it is easy to calculate and more widely used statistic, it is very sensitive to extreme values. So, suppose 1, 2, 3, 4, 5. Okay. Now, the average of this is 3. 1, 2, 3, 4, 5. The average of this is 3. Now, the moment I add, this is 5 values. Okay. Now, the moment I add 30 to this, okay, 1, 2, 3, 5 is one chunk, 1, 2, 3, 4, 5 is one chunk, and I add 30 to this. The total becomes 18. Okay. Now, 18 divided by 6 is how much? 6. So, the mean has shifted from 3 to 8. 48 by 6 is 8. Okay. Let us do it by on paint. So, 1, 2, 3, 4, 5. Okay, just a second. One, 2, 3, 4, 5. The mean is 3. Okay. Let me increase the font size. Now, if we have 1, 2, 3, 4, 5, and let us say we add 40 in this. Okay. What does the mean become? Let us add 39. okay, let's say 49, 40, okay. The mean becomes 55 by 6, which is around 9 point something, okay. Now this is called sensitivity just by adding one variable, one value, one extreme value. Okay. So please understand this. The mean is very sensitive, extreme, either ways, either to the maximum side or to the minimum side. And this is very important. The sum of deviation of numbers in the data from the mean is 0. Now what does it mean? What it means, that if the average is 3, then the difference from 1 and 3 is minus 2, the difference from 2 and 3 is minus 1, the difference between 3 and 3 is 0, and so forth and so forth. So sum of deviation, so sum of deviation is 0. This is very important, okay. So that is a unique property. So mean is more convenient and more useful when the data is nearly uniform, the variability is less, and we will talk about that later, okay. So as we can see here in the example, I told you, okay, median is the 50% of the data in the row when sorted. Again I am repeating, when sorted out. So you have 1, 2, 3, 4, 5, okay. Now if you put that value 5 and make it to take it to 10, still the median will be 3. In the here, if I change one value to another, I took 5 to 10, the value changed, okay. So please understand, the median is not affected by extreme values. Median is possible for a ordinal data, okay. Now this is very simple. When the number of events are odd, then you have the median as the middle number. When the values are even, okay, like you have 6 values. So in this way, the median is average of 2 middle numbers, okay. Now that is one thing, it's not that much deviant, it does not add that much problem, because we need to get the n plus 1 position. So in odd it is possible, and even we need to do an average of that, okay. Mode. So as I told you, mode is the most occurring number, the value that occurs most often, or value whose frequency is most. Yesterday in the histogram, which we were earlier classes, we were talking histogram of JP01. So the value 4 has the highest value and the histogram, that is the mode, okay. So mode is possible for all numerical data also, okay. It is possible that there is no mode, or it is multimodal. Now what does multimodal means, and we will talk that later. Suppose here 9 is appearing 3 times, what if 12 also appear 3 times, and 2 or 3 appears also 3 times. So it can be multimodal. So we will not go in those details, but yes, mode is the maximum type the number of data happens, okay. Now which measure is the best location of the best, like which among these three should be used. Now this is what we have to understand. As I told you, if the outliers are not involved, then go for mean, okay, and otherwise go for median, and we will see the example of this in day-to-day life. Again, summarizing all of these things, Mean is the appropriate measure of central tendency for interval and ratio variables. Median is ordinary statistics. Okay. Mode is a nominal statistic. This we have already talked about. We will talk about this later. Now, this is what I was trying to tell you. This is an IIM Ahmedabad placement report. Most of us are looking for placements in IIM Ahmedabad, and that's the most widely talked statistic. So, the highest salary, the lowest salary, and the average and the median salary. Okay. Now, this is very important. I did tell you that it is not just the average salary, it is also the median. So, both will be talked about. And this is a link I have given. This is I suppose 2-3 years old report. So, both median and both average has to be talked about. Now, sometimes the median is less than the mean and sometimes the median is more than the mean. Okay. And which is more favorable, we will talk about that later. We will talk when we will do skewness, but for the simplicity right now I will just give you a little hint. When the data is symmetrical, like the middle figure, mean, median, mode is same. So, mode is the highest value, number of time values are occurring, the mean is the average of all sides and median is the middle one. Okay. It is same, but when the data is skewed means it is not symmetric, let us put it, or it is asymmetric. Now, there can be two sorts of asymmetry. One is having more positive entries, one is having more negative entries. We will not talk about that right now, we will talk when we talk skewness. Okay. So, in a positively skewed, when there are more positive entries, it is remembered by a P. So, you can see there is a P forming here and there is the inverse P forming here. So, this is a positively skewed data, the mean is more than the median, and which is what we can see here. The mean is more than the median, which means that there are people who are outliers on the positive side. Okay. On the other hand, if the mean is less than the median, then you can say there are outliers on the negative side, more outliers. Okay. So, with that we will end the slideshow and we will just go to the software right now. Okay, we are getting the values. Okay. So, the earlier plugin also worked, it somehow crashed. So, again we will do it for the data descriptive statistics, median, mean, and let us do for JP01 and JP01 also. Now, you are getting that mean, median, mode, missing values, valid values. Okay. So, as I told you, here we have more information, we have harmonic mean also, we have minimum maximum also, standard deviation, everything that is available in this analysis tab. That therefore, I said for the teaching thing we might use this. This is an add-on plugin. Okay. It is more useful for us, but advanced plugin is this one, this will have more options. So, please understand we are done with the mean, median, mode, center of tendency, and now we will meet to discuss measure of variability. Okay.